So I mentioned the nebular theory is one that basically describes the formation of our solar system, the sun, the four rocky or terrestrial planets, actually then the asteroid belt, Crumbly's left over, then beginning the gaseous or the Jovian planets. And so like is required by the make sense scientific method, we need to, when we come up with a theory like that, we need to consider what our observations are. So our observations then need to, for instance, account for what we see here. One of our observations is that all the planets generally orbit the sun in kind of like a frisbee or a plane or a record, actually, if you kind of think of them as tracks in orbit about the sun. So we need to explain that. Another thing to explain, got some explaining to do, and it's really not too much of a stretch when we talk about, in the next part, the nebular theory itself, is this rotation, this spinning. So all of actually you see the sun in the middle actually spins on an axis. So also do all the planets spin on an axis, and the planets also orbit in the same direction that they usually spin. Okay, so the sun's spinning, the planets are orbiting, the planets are spinning. Okay, kind of all in the same direction. If we're kind of looking down at the North Pole of the Earth, it's counterclockwise like you see here. So we need to explain that. I mentioned kind of the difference between the inner rocky planets, of which the Earth is the third planet, right? And then the Jovian planets. Why is there such a big difference between kind of the nature of these planets? We're going to talk about something called a frost line coming up to kind of explain that temperature-wise when they were forming. The other thing, and I think I mentioned this earlier, is there are some Crumblies beyond, I know I mentioned this, there are some Crumblies out there. Actually, Pluto was kind of assigned, or Pluto we think is beginning what we call the Kuiper belt more than its own planet. Let me kind of emphasize. Okay, so the Kuiper belt shown here is in the plane of the ecliptic, starting about Pluto, Eris, and etc. So there's leftovers out there. There's also leftovers out in this thing called the Oort cloud, and the Oort cloud is like a sphere of icy, rocky material, Crumblies, again, that is gravitationally associated with our sun. Okay, when we get some of these kind of miscellaneous rogue comets, okay, they're icy, comets are icy, and comets come from the Kuiper belt or sometimes the Oort cloud. Okay, but comets basically got nudged by one of the gaseous planets and kind of changed its trajectory and is set on a path to orbit the sun, come closer. So we need to explain that, and that's not too bad. Another couple things we need to explain, I'll kind of show you the collision ejection theory that kind of says how Earth got its beautiful moon that is kind of disproportional to its size. And then also we need to explain how, remember I said Uranus's axis of rotation, that's kind of Uranus. Uranus's axis of rotation basically lies in the plane of the ecliptic. It's like, what's up with that? Okay, so actually the collision ejection that formed Earth's moon and the tilted axis of rotation, we think basically there was a bunch of stuff running around early on.